On Earth, it's impossible to go very long without seeing the Sun. This enormous ball of atomic fire rules the sky because it is the largest body in the solar system. The Sun isn't that enormous for a star. In fact, it's about average in size, yet it dwarfs anything nearby. The Sun appears enormous from our vantage point. However, it does not appear to be as large when viewed from the outer reaches of our galaxy. So are there any larger stars in existence? Absolutely. Our Sun is a yellow dwarf, which is a little smaller than the normal star in size. The big stars make our Sun appear insignificant. So what is the biggest star ever discovered in the universe? How big and frightening can they really get? Let's find out. Our Sun receives a lot of attention in terms of stars. Life on Earth practically revolves around it, and from our vantage point at least, it dwarfs the other stars in the sky. The Sun appears smaller when viewed from the remote reaches of our galaxy though. In actuality, its size is rather typical. First, let's talk about stars. There are many distinct kinds of stars. Some are bigger than others. However, before moving on, you must realize that stars don't have neat, defined boundaries. They do not have a rocky planet or a moon's solid surface. Instead, the superheated mass of gas that makes up these atomic fireballs slowly thins out into nothingness, leaving them with somewhat dispersed surfaces. A star's photosphere, which is the point at which the star turns transparent, is what astronomers use in place of a surface, i.e. where photons can escape the star. So from now on, be aware that when we refer to a star's surface, we actually mean its photosphere. The second crucial point to keep in mind is the fact that we have never directly measured a star. Nobody went up to one with a ruler and started adding up distances. We do, however, have estimates, mostly accurate estimates, but nonetheless estimates. These estimates can be more or less precise and fall within a smaller or larger area of confidence, depending on a variety of factors, such as distance or structures around stars or between them and Earth, i.e. we know it's between X and Y miles or kilometers wide. You might recall learning in a science class in school that the Sun is actually a star rather than a planet. The Sun can appear enormous when you stand outside throughout the day and look up. You can conclude as a result that it is the biggest star in the galaxy. However, UY Scuti is hundreds of times bigger than the Sun. The Sun appears larger in part because of its proximity to the Earth. Although the Sun is a huge star, it is not by any means the largest star in the cosmos. What is the largest star that has been discovered in the universe? The answer depends on whether you're referring to a star's mass or total volume, or how much space it occupies, according to Phil Massey, an astronomer at the Lowell Observatory in Flagstaff, Arizona. When it comes to size, the heavier stars are frequently unimpressive, while the most massive stars are frequently faint stars. That's because older stars have the propensity to expand and lose mass. The tallest people might not weigh the most, Massey added, comparing it to humans. Consider that you are discussing mass. The star R136A1 holds the record there. It is situated in the Large Magellanic Cloud, a tiny galaxy that revolves around the Milky Way, around 160,000 light-years away from Earth. Imagine a cherry next to a gigantic yoga ball that is more than 200 times more massive. This star is 30 to 40 times the size of our Sun in terms of diameter. This star is also quite young, having lived for only 1 million years as opposed to our Sun's 4.5 billion years, and hasn't done any cooling off or expanding. There are several contenders if the definition of the largest star in the universe is the one with the largest diameter, and UY Scuti is at the top of that list. Astronomers at the Bonn Observatory in Germany first noticed it in 1860 and gave it the designation BD-125055. After more observations revealed that BD-125055 changes in brightness and magnitude over the course of 740 days, it was determined to be a variable star. The diameter of this red hypergiant is approximately 1,700 times that of the Sun. Remember that supergiants are bigger than giant stars, while hypergiants are bigger still. Hypergiants are extremely rare and have dazzling lights. Additionally, they lose more mass to stellar winds than smaller stars do. If UY Scuti were to replace the Sun as the primary star of our solar system, its photosphere would reach beyond Jupiter's orbit, giving you a sense of its size. Jupiter and the Sun are separated by 484 million miles, or 779 million kilometers. A 400 AU long nebula would be formed by gas coming from the star. 1 astronomical unit, AU, is the distance between the Earth and the Sun. This would effectively extend well beyond Pluto's orbit. The average orbiting distance between Pluto and the Sun is 39.5 AU. UY Scuti would be a spherical 10 stories tall if the Sun were a cherry. But measuring the diameter of very far-off stars is fraught with uncertainty. UY Scuti is located in the constellation Scutum, other words, Shield, approximately 9,500 light-years away from Earth, give or take 1,000 light-years. Because stars seem brighter up close and dimmer at a distance, astronomers must know how much light the star produces in order to do this. You end up with a wide margin of error when you combine that with the fact that red hypergiants like UY Scuti are frequently variable, meaning their brightness changes over time. Variable star sizes frequently change as a result of variations in brightness. For instance, according to research, the radius of UY Scuti may be up to 192 solar radii greater or smaller than previously thought. If the lowermost value is accurate, other stars would be larger than UY Scuti by about 30 times its smallest estimated size. Red hypergiants are difficult to model because of their extreme messiness, according to Massey. The surfaces are always moving. On the other hand, WOHG 64 might be the biggest star in the cosmos if it weren't for UY Scuti. Approximately 170,000 light-years from Earth, WOHG 64, that's 1,504 to 1,730 solar radii, is a red hypergiant in the Large Magellanic Cloud in the constellation Dorado, in the skies of the southern hemisphere. This star's brightness varies over time, in part because of a dust cloud in the form of a torus that blocks out some of the star's light. The star most likely created the torus while it was dying. WOHG 64 once had a mass greater than 25 times that of the Sun, but as it got closer to going supernova, it started to lose mass. It has lost between 3 and 9 solar systems worth of material, according to astronomers' estimates. Additionally, there is VY Canis Majoris, which is 8.2 million years old. Originally thought to be between 1,800 and 2,200 solar radii in size, the red hypergiant star VY Canis Majoris has since had its estimate revised down to 1,300 to 1,540 solar radii. The diameters of WOHG 64 and VY Canis Majoris are both about 1,500 times larger than the Sun. Furthermore, either could surpass UY Scuti in size given the ambiguity. In either case, it is quite cool. All of the inner planets, including Jupiter, would be engulfed if any of these stars took the place of our Sun at the core of our solar system. Massey said, the Earth, all the inner planets, would be vaporized. What about Betelgeuse? Betelgeuse was Michael Keaton's real name, as fans of the popular film Beetlejuice may recall. One of the biggest stars in the cosmos is one of the same name. This star, which becomes visible each year in October, can be seen with a telescope. Additionally, the star is still visible through the end of May. It is located fewer than 700 light-years from Earth and is closer than other stars. Red supergiant Betelgeuse, 950 to 1,200 solar radii, is located in the constellation Orion. Being the 9th brightest star in the sky, Betelgeuse is one of the most well-known stars of its kind. This star is on the verge of going supernova and is predicted to do so at any moment. However, even if our Sun is not the largest star in the cosmos, it is also not the smallest. What is the smallest star that is known? EBLM J055557AB. That has earned this distinction. Scientists noted that EBLM J055557AB is smaller than Saturn and just about manages to qualify as a star. If it had a lower mass, it would be considered a failed star known as a brown dwarf, since it couldn't support nuclear fusion at its core. These stars are merely those that are in our immediate cosmic neighborhood. The universe is, of course, vast. Massey pointed out that we are unable to gauge the size of stars on the other side of the Milky Way, let alone those in the far reaches of the universe. There's too much dust, there's too much interference with light, he added. And even though UY Scuti and EBLM J055557AB are getting close to the upper and lower boundaries of what a star may be, respectively, we still don't know how massive or heavy stars can become. Keep in mind that because stars are balls of extremely hot plasma, they don't have a linear relationship between weight and size like, for instance, cannonballs, where the largest shell is obviously heavier. Ironically, R136A1 is only roughly 30 solar radii in size, while having a mass 300 times that of the Sun. Despite being much larger, UY Scuti is only 30 times more massive than the Sun. The extremely high surface enhancement of heavy elements, which are dense, and hydrogen depletion in R136A1 can be used to explain its mass, which is light. The fact that stars' sizes can alter throughout time is crucial to remember. Its transformation into or attainment of the status of a supernova is the most frequent source of this size change. According to NASA, a supernova is a star that has experienced an explosion that causes it to shed a sizable amount of its mass. A dying star releases its mass into the universe and forces it there. Some of that mass may be absorbed by other stars, increasing their size. Astronomers and NASA have compiled a list of stars that are close to going supernova. A telescope is the best tool for viewing some of the largest stars in the cosmos. A professional or base model is available that enables you to see the stars and constellations like Orion and the Big Dipper. You can also go on a tour and look through a bigger telescope if you live close to an observatory. Many of these facilities are accessible to the public. While UY Scuti is the largest star in the universe, a telescope can also be used to observe other large stars. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.